When other people are trying to modify data that we might be in the process of trying to read or otherwise work with, we can wind up with some potential issues that we're going to go through here in the section of concurrency issues. The first little problem that we can wind up running into is what's known as a lost update. And a lost update simply means that I went in, I issued some form of an insert, an update, or a delete statement. SQL told me, hey, this has been committed. But when I go back to read the data, that update is now gone. So somebody changed the data that I was in the process of trying to modify myself. The next possible issue that we can run into is what's known as a dirty read. A dirty read is where somebody is reading data that maybe someone else or myself is in the process of trying to modify. The problem with a dirty read is that I'm now going to wind up with inconsistent data. For example, maybe I'm in the process of trying to read orders and the associated order details. While I'm reading all of that, somebody else comes along and they modify an order that I was in the middle of reading, and they modify maybe the date or total due or something like that. And now I'm reading data that might be committed, might not be committed, might be in the process of doing something else. That's a dirty read. A non-repeatable read is when I execute a query, I get back, let's say, 5 rows, I execute that exact same query as part of the same transaction, and I get back 5 rows, but there's different data inside of there. Contrast that with what's known as a phantom read. A phantom read is where I issue a select statement, I get back 5 rows, and inside of the same transaction, I issue the exact same select statement, and now I get back 6 rows. That 6th row is a phantom read. Now, to try and help explain each one of these, the next handful of slides have a few examples. You'll notice, first of all, a lost update. And a lost update would be where my user 1 over there begins a transaction, says update person.contact set last name equal to Harrison, where contact ID equals number 42. User 2 comes along and they say update person contact set last name equal to Baxter, where contact ID equals 42. And that operation succeeds. I was in the middle of trying to modify some data. What happened to the modification that I was performing? That's a lost update because that's now gone. It's now been replaced with Baxter. The next possible issue that we have is what's known as a dirty read. User 1 comes along, begins that same transaction. User number 2 comes along, and they issue a select statement where they're looking for the last name from person contact, where the contact ID is 42. The dirty read would return Harrison. The reason that it's a dirty read is because somebody's in the process of modifying this, but they have not yet written that out to disk or have not actually committed the transaction. The next possibility is a non-repeatable read. Now you'll notice with a non-repeatable read, we do a select inside of a transaction, and that's going to return whatever the value is. Let's just say the last name is Harrison. And then over there, we've got user 2, and user 2 issues an update statement. Now, if that update statement is allowed to commit, when I issue my second select statement, I'm now going to get back the value of Baxter. Contrast this with what's known as a phantom read. The big difference between a phantom read is that in a phantom read, we get new rows. So you'll notice over on the right-hand side that we do an insert statement. And on the insert statement, that inserts in a brand new row. And then when I issue my select statement a second time, I now get that brand new row. That brand new row is that inserted row. That is my phantom row, my phantom record, my phantom read. The problem with trying to prevent a phantom read is that it requires me not only lock data that we know about, but it requires that I lock data that I don't know about. Because in order for me to prevent somebody else from coming into that result set of last name equaling Baxter, I have to prevent not only the existing Baxters, but I need to prevent anybody else inside of that contact table from becoming a Baxter. This can require locking a very large section of data and potentially the entire table. Now that we've discussed all the different things that can go wrong, let's now discuss how we're going to control that. The way that we control this is by utilizing what are known as isolation levels. Isolation levels allow me to control how data is going to be locked. Now, what you're going to notice is that the syntax is set transaction isolation level and then set it to be whatever option it is that you might want.